Alright, welcome you guys. This is pre-calculus A. These are all the basic trig identities. These are called the reciprocal identities. Reciprocal identities. Okay, and they go as followed. Pythagorean identity we will work on, and I'll show you how to arrive to the other ones. And even and odd functions are right here, and co-function identities are right down here. I should probably put that hyphenated. Let's make that hyphenated. There we go. That looks a lot better. Okay, so right here is the basic trig identities. Basically, it's just proving that one's reciprocal of the other. So sine is equal to 1 over cosecant. Cosine is 1 over secant. Tangent is 1 over cotangent. Also, the famous one that we've talked about before, tangent is sine over cosine. So this explains all of that. Okay, now it also has the backups. So cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, or cosine over sine. So there's all of those identities. Now what these identities are designed for is for you to transform something that's a little bit more complex and change it into something that's easier to work with. That's the whole idea behind it. Okay. Now, Pythagorean identity, the main one is, and it comes from the idea of making a triangle in the unit circle. Okay, so we have, whoops, accidentally drew a box. Let's get rid of that. Okay. Alright, and so we just take a look at this. Now, if we actually draw our triangle right here. Okay, so we have our right triangle. Since that's a right triangle, the y side is going to be sine, and the x side is going to be cosine. And guess what? If I square both of them and I add them together, I get the third side. Okay. Now, why was this designed? So you can turn this into this. Simple as that, and that's always true. Now, when we're talking identities, identities are true for every single angle you could ever think of. Go ahead and go try it out in Desmos, and it will always be true. Now, before I really start on it, sine of x means you're taking sine of x and you're squaring it. Okay, so when you see that, you're actually squaring the actual function. Now, to get the other two Pythagorean identities, we actually divide everything by either sine squared or cosine squared. Okay, so this is the really fun part. Okay, so I've re-represented them as I divide this one entirely by cosine of squared of x, and I divide this one entirely by sine of x. Now here's the cool thing. I'm going to use these identities to rewrite these. So first off, I look for, okay, I'm going to look right here. Oops, nope, right there. Okay, so I'm going to look at that and go, okay, what is sine squared of x over cosine squared of x change to? Now, obviously, these also apply to the squares. So I quickly look and I see, oh, sine of x over cosine of x is tangent. So this becomes tangent squared of x. Ta-da! It's pretty nice, huh? Now cosine of x, cosine squared of x over cosine squared of x just turns into a simple 1. That's the beautiful thing about it. And 1 over cosine squared of x, if I look up here, I'm going to see that it's secant squared x. If you're wondering how I'm making those cool little 2's, those are squares, and that is alt 0178. Okay. All right, and that's another trig. That's another Pythagorean identity. That's the beautiful thing about it, is that the other two identities are derived from that. Okay. All right, down here, this is going to turn into 1 because that's the same thing over itself. And then cosine over sine is going to be cotangent. So it becomes cotangent squared. And 1 over sine squared becomes cosecant. Oops, undo. Well, shoot, that sucked. I guess I found out the limitations of the undo button and the do up button. Right? And that actually turns into another one. Now, the cool thing about identities that have already been verified is you can remanipulate them to become new identities. Alright, so for example, like on this one right here, let me move it over a little bit so you can see each one in its full glory. These things are amazing because I can actually arrive to 9 identities from just knowing one. Okay, so in other words, on this one I minus the cosine squared of x, and on this one I minus the sine squared of x. So these are another 2 identities I can use to simplify. Once again, identities are Trig's way of factoring. It makes your job easier if you can change something complicated into something less complicated. Tangent squared, if I minus 1 from both sides, tangent squared can be arrived to if I take secant squared x and minus 1, or 1 can be arrived to if I ever have secant squared x minus tangent squared x. And then same thing down here with cosecant and cotangent. Okay, now the even and odd functions are what happens if I plug in a negative angle in here. What happens? Okay, so if I plug in a negative x or negative whatever, it's the same as if I did the negative of the sine of that. So let's say I pick 30. Okay, so if I do sine of negative 30, that's the same as the negative of sine of 30. If I do the cosine of negative 30, that's the same as cosine of 30. It's a really cool thing because that makes this an even function. Okay, and if I do tangent of negative 30, that becomes the negative of tangent of 30, and that makes these two odd. So you know your even and odd functions now just by knowing some identities. Okay, all right, now cofunction identities aren't used a whole bunch, but it's kind of nice to know that when you're dealing with sine and cosine, whenever you do sine of an angle, the cosine version is going to be equal. So once again, let's do 30. So sine of 30 is the same as cosine of 60. Why? Because of this identity. And we're minusing 30 from 90. Cosecant of 30 is the same as secant of 60. Cosine of 30 is the same as sine of 60. Secant of 30 is the same as cosecant of 60. And tangent and cotangent just follow their own rules. They're their own little pals. Tangent of 30 is the same as cotangent of 60. Oh, I could have written down the other one. And cotangent goes obviously the same way with it. Okay, but that's all your basic trig identities, and what you're going to be doing is just simplifying some really complex trig down into simpler trigs. Wherever you see something, always refer back to this notes or however you take this section, and just refer back to these identities and go, okay, what can I simplify? What can I make my job a lot easier with? Okay, all right, thank you. Bye.